How can you locate fractions and decimals on the same number line? Think about this question during the lesson. Jules is playing a game in which she draws 3 cards. Each is labeled with a fraction or a decimal. Then she must locate a point for each number on a number line that is divided into 10 segments between 0 and 1. In your own words, what does Jules want to do? Jules wants to place fractions and decimals together in the correct order on the same number line. You know that 9/10 also means 9/10. You can easily locate 9/10. Show 9/10 on the number line. Why is it easier to locate 9/10 than 3/20 or 617 thousandths on the number line? 9/10 falls exactly on a point that is marked while the other 2 numbers fall between points. Now locate the fraction 3/20. You know that 3/20 means 3 divided by 20. You can use division to find that 3 divided by 20 equals 15 hundredths. 1/10 equals 10 hundredths, and 2/10 equals 20 hundredths. So, 15 hundredths is halfway between 1/10 and 2/10. Now locate the decimal 617 thousandths. 6/10 equals 600 thousandths, and 7/10 equals 700 thousandths. So, 617 thousandths is between 6/10 and 7/10. It is closer to 6/10 than 7/10. Before the points were plotted, would you expect 617 thousandths to be between 3/20 and 9/10? Why? Yes, you can see that 617 thousandths is greater than 5/10, or 1/2, and that 3/20 is much less than half. Is 9/10 greater than or less than 617 thousandths? 9/10 is greater than 617 thousandths. You have seen the location of different fractions and decimals on a number line. On the number line, where would you place the fraction 13/16? Try it yourself.
Mathematicians, in this lesson, you are going to learn how to place a fraction with a numerator of 1 on a number line by breaking the whole number 1 on the number line into smaller parts. You know that when we talk about fractions, we are talking about equal parts of a whole. That means we are talking about one whole number being broken down into smaller equal parts. For example, if I get 1/3 of a pie, I am getting one piece out of a total of 3 equal pieces. That means that I am getting a piece that is bigger than 0 or bigger than none of the pie, but my piece is less than 1 or less than the whole pie. Fractions are parts of a number that are greater than 0 but less than 1. Here is a number line. We know that number lines show numbers in order as they move from smallest to largest. Each number has its own spot on the number line, which is usually shown with a tick mark. Each number's spot is equally spaced from the number before and after it. That's because each space represents the same amount. Let's say our unit that we are counting with is base 10 blocks. Each space between the tick mark would show or represent 1 unit block, like this. At 0, we would have no blocks, but the space between 0 and 1 would show 1 block. Then the space between 1 and 2 would show 1 more block, so that we have 2 unit blocks. And the next space would show 3 unit blocks, and so on. If the whole number 1 has a spot on the number line that represents one unit block, and we know that a fraction is a part of a whole and is less than 1, if we break the space between 0 and 1 down into equal parts on the number line, we will be able to locate or find a fraction spot on the number line also. Let's say we want to find where the fraction 1/3 is located. In order to do this, first we would have to find the space between 0 and 1. We know that 1/3 is more than 0, but less than 1. So let's zoom in on just that space. All of the space between 0 and 1 are fractions of the number 1. I know that the denominator of any fraction tells me the total number of parts that the whole is broken into. If our whole is the number 1, we are breaking the number 1 into 3 equal parts. I could think of breaking the unit block into 3 equal parts, or I could break the space on the number line between 0 and 1 into 3 equal parts. We know that when we break something into 3 equal parts, we break it into thirds, like this. I could count each of these equal pieces by thirds: 1/3, 2/3, 3/3, or like this: 1/3, 2/3, 3/3. Now remember, I was trying to find the spot on the number line where 1/3 was located. I would look at the numerator, 1. The numerator tells me I'm thinking about just one part, so I'll shade in just one part. This is what it would look like if I were shading in just one part of the unit block. When I shade in just one space on the number line, it looks very similar. The spot where I land right here is the spot for 1/3 on the number line. This space right here is one of 3 equal spaces between 0 and the whole number 1. If we zoom back out on the number line, we can follow the same steps to find 1/3 in relation to more whole numbers. The space between 0 and 1 gets split into 3 equal parts. I shade in one of those equal parts and label it as 1/3. Let's see how this works in a problem. Let's say we want to find where 1/4 is located on a number line. First, we would look at our number line to find the space between 0 and 1, because we know the fraction 1/4 is more than 0, but less than 1, and we would zoom in on that space. Then we would look at the denominator of our fraction, because we know that the denominator tells us the total number of equal parts into which our whole number is broken. It says 4, so we would need to break that space into 4 equal parts. If we break the space on the number line into 4, it looks very similar. The numerator tells me I'm thinking about just one of those pieces, like this. So I would hop just one space from 0 to here. This spot is where 1/4 is located on the number line. This space right here shows or represents one part of 4 equal parts that the whole number 1 has been broken into. If I zoom out, I can follow the same steps to find 1/4 on the number line. The space between 0 and 1 gets broken into 4 equal parts. I shade in just one of those equal parts and label it as 1/4. Now you know how to place a fraction with the numerator of 1 on a number line by breaking the whole number 1 on the number line into smaller equal parts.